We will be discussing rain gardens as a potential solution to the current environmental impacts on Hamilton Harbor. The city of Hamilton was incorporated in 1846 and has a population of over 500,000 people. A city this large that has been around for 170 years has seen many changes in technology and infrastructure. One of these changes in infrastructure is evident when examining the sewer systems of Hamilton. The older parts of Hamilton have what is called a combined sewer system, while the newer areas have a segregated sewer system. A combined sewer system means that both the storm sewers from the street and the sanitary sewers from houses and businesses flow into the same sewer pipes to a combined storage tank. If the system is segregated, the storm flow sewers and sanitary sewers never interact and have separate destinations. There are over 52 square kilometers of sewers in Hamilton. As technology continues to evolve, there are new ways to manage sewers. For example, Hamilton sewers now have real-time control, which means that the weather in different areas is taken into account to try and reroute areas that will have high rainfall to avoid overflow of the storage tanks. The problems that are associated with combined sewer systems are significant. Even with the real-time adjustments that can affect where the sewers flow, there is still a very real risk of the storage tanks hitting their maximum level. As the sewer system is fairly old in some areas, the tanks are not built for the amount of people it now services. Also, the increase of building and other impermeable surfaces diverts more stormwater to sewers than ever. When a storage tank reaches its maximum, there is a combined sewer overflow outfall, which basically just releases untreated sewage from the storage tanks directly to, in this case, Lake Ontario.
The most prominent and degenerative impact of domestic and industrial sewage wastewater arises from the presence of highly toxic, chemical, microbial, pathogenic, and organic particulate contaminants. These wastewater contaminants have an extensive range of associated degenerative effects. You have suspended and dissolved organic particulate matter, which attributes to a reduction in dissolved oxygen concentration in water bodies, as the decomposition process induces the usage of all available dissolved oxygen. You have chemical toxin contaminants present in sewage, which are toxic and conducive to the chronic and acute deficiencies and subsequent mortality. You also have pesticides, persistent organic pollutants, and heavy metals, which are all conducive to immune suppression and have the potential of bioaccumulation within tissues to induce subsequent long-term toxic physiological effects. Some examples of persistent organic pollutants include PCBs and PAHs, which have the associated capacity as endocrine disruptors, inducing deficiency in both sexual and bone development in aquatic organisms. So as you can see in the next slide, this table articulates sewage wastewater contaminant concentrations in Vancouver, and you can see that all average sewage concentrations exceed the functional threshold capacity. Of course, with all direct implications, you have the associated indirect implications. As I mentioned, there are the ecological implications. Residual toxic contaminant wastewater discharge is conducive to negative effects on ecological processes and systems. You have economic indirect implications, which the costs associated with preventative and mediation measures. To put this in perspective, Canada has an approximated $10 to $13 billion expenditure allocated on wastewater sewage treatment and remediation per year. And the social implications, of course, are the health deficiencies on households and residents. So what is the optimal solution?
Rain gardens are distinctly landscaped areas of a residential property built to replace an area of the lawn. Rain gardens are built to catch and collect water runoff from lawns, roofs, or driveways caused by rain and snowmelt. Rain gardens are able to collect the water through their design, consisting of a shallow depth and loose soil filling out the garden. The design of the gardens and the specific types of vegetation used allows the water to be absorbed instead of it moving into the city storm drains. Rain gardens can be made to personal liking and preference through the design process. A typical rain garden consists of 3 zones used to designate certain types of vegetation. Each zone is meant to handle different amounts of water based on the plants making up each zone. The zones move out from the center of the garden to the outer edge, and Zone 1 should be filled with plants that can tolerate large amounts of water for extended periods of time. Zone 2 consists of plants that can handle saturated soil occasionally. And lastly, the third zone does not experience long periods of wetness, therefore, plants in this zone can survive in drier climates.
There are many benefits of residential rain gardens for water treatment plants and waterways. The rain gardens capture water from residential sources and reduce the amount of runoff that enters the combined sewer system, and thus reduces the likelihood of an overflow into attached waterways. The installation of rain gardens would reduce flow rates, volume, and duration of combined sewer overflows during the heaviest rain events. Rain gardens also filter some potentially harmful pollutants like total nitrogen, phosphorus, ammonium, and heavy metals. Since the waterways become cleaner, remediation by various parties could become less demanding. There are also many personal benefits of installing a rain garden on your property. Once a rain garden is set up, it is easy to care for, and once a depression has been made for the garden, costs of planting are similar to traditional landscaping. Initial costs can be offset by the decrease in water consumption costs since rain gardens require little additional watering. Since there are a vast amount of plants suited to this environment, rain gardens can be designed to fit aesthetic preferences. The types of plant species that thrive in a rain garden can provide habitats for birds, butterflies, and insects like dragonflies that consume mosquitoes.
Rain gardens are very easy to install, and there are several services available to make the process easier. There are several different methods of building a rain garden. The one step that all rain gardens have in common are choosing a designated area and digging it up. You then fill the hole with various substrates to provide different levels of filtration. One possible combination is to have a bottom layer of gravel, a thin layer of sand, and a final layer of garden soil. Once the layers are in place, flowers and plants can be added. Plants aid in the filtration of water and shelter the soil from heavy rainfall. Once the plants have been situated, your roof drain can be redirected into the gravel layer of the rain garden using a slotted pipe. The links in the description box are some of the resources available in Hamilton to help you get started on building a rain garden in your yard. Building a rain garden in a residential setting will cost about $3 to $4 per square foot. Building a rain garden in industrial areas may cost between $10 and $40 due to requirements such as larger drains and more labor for construction. Although there are initial costs to building rain gardens, there aren't many costs for maintenance.
In order to speed up the transition to widespread rain garden installations in Hamilton, we can offer appealing incentives. The Hamilton municipal government can provide tax cuts and rebates for households that install rain gardens in their yards, provide cost-reduced building materials, and provide assistance to residents who need help with the technical aspects of installation. We can also bring awareness to the benefits of rain gardens by educating the community. As residents of Hamilton, rain gardens are an easy and optimal way of reducing pressures on Hamilton's sewer systems. So grab that umbrella and make it rain gardens.